All right, ladies and gentlemen. So let's get started with today's review. Today we're going to talk about equations of graph. Okay, so we're kind of doing the opposite of what we were doing in our previous video, where I would give you an equation and you would graph it. Now it's kind of like where I'm giving you a graph and then you have to draw an equation. So real quick, what I'm going to do, and I'm actually on page 98 of your textbooks. What I'm actually doing is I'm reading where it says key concepts, and I'm going to go over some of the basis or important things that we need to do for when working with this topic specifically. So let me find the page real quick so I can go ahead and do that with you guys. So the key concepts again on page 98 of your textbook says, for example, if you're given a slope, let's say I'm giving you m and I'm giving you b, which is the y-intercept, and what I want you to do is I want you to write an equation based on what I'm giving you. So if I give you a slope and I give you a y-intercept, you would express them in using this equation: y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so sometimes you can have y equals mx plus b, or sometimes you'll see something like y equals mx minus b, and it's just because remember that subtracting is the opposite of adding, and when you're subtracting negatives, you're adding the opposite. So if you see y equals mx minus b instead of y equals mx plus b, it really doesn't make a difference. It's the same thing. Okay, so if I give you a slope and a y-intercept, well, then that means that the equation that you're going to use is what we call the slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. Now, what if I give you an ordered pair x sub 1, y sub 1, x sub 1, y sub 1, and I give you a slope? So if I give you an ordered pair and then I give you a slope, whatever number that slope may be, how are you going to write an equation for this graph? Well, you would use the what we call the point slope form, which is basically the formula says y minus y sub 1 equals m times x minus x sub 1, I'm sorry, times x minus x sub 1. So basically, if I give you something like this, what you're going to do is plug in the numbers into this formula and pretty much just turn this equation, solve for this equation, and turn it into y equals mx plus b. And we're going to see that in just a minute with some of the examples. So if you're still kind of like, you know, asking yourselves, what is he talking about? What weird language is this? What is this witchcraft that I don't speak? Don't worry, you'll get it in a minute when we start seeing some of those numbers, all right? So again, if I give you the ordered pair and the slope, what you're going to do in that case is basically use the point slope formula, which is y minus y sub 1 equals m times x minus x sub 1. And then you're going to turn your answer into y equals mx plus b. Now, what if I just give you an ordered pair? What if I just say, well, or two ordered pairs? What if I give you x sub 1 and y sub 1? And x sub 2 and y sub 2. What if I just give you that? What if I give you that? I give you no y-intercept or anything like that. What do you do? Well, in this case, you would have to first calculate the slope. So you would have to use the slope formula, right? So this one is actually kind of like a two-step or three-step problem. First, you would use the slope formula, which we all know is m equals y sub 2 minus y sub 1 and over x sub 2 minus x sub 1, okay? So what you guys would do in that case is you would first calculate the slope. And then you would use the point slope formula. So basically after that, you would take one of those ordered pairs, whichever one you want, and you would plug them into this formula that I'm going to write now. Y, which is pretty much the one I wrote a minute ago. Y minus y sub 1 equals m times x minus x sub 1. So basically, what you would do in that case is first find the slope, and then when you get the slope, you plug or you use the point slope formula to take one of those ordered pairs, whichever one you want, and you plug them into that one, and then you just solve until you get your formula in slope intercept form. So basically, when we're working with equations of linear functions specifically, we pretty much always want to leave it expressed in the slope intercept form. So pretty much we're always going to make sure that our answer is something like this. So even if I just give you two ordered pairs, you have to find the slope. Then you take that slope and you plug it into this formula specifically. I'm sorry. You find the slope, and then you plug in that answer into this formula right here. And then ultimately your goal is to make sure that your answer equals the slope intercept form. So let's actually just go ahead into some of the examples, and maybe it'll start making more sense to you guys after I do that. Maybe not. I don't know. But hopefully it will. Hopefully I am able to explain this to a point where you guys feel confident working with these exercises. So in example number 1 of your textbook on page 98, you have a graph. You have your x-axis and your y-axis, right? And you have an ordered pair, which is 0 and -2. So that'd be your 0, -1 would be here, and -2 would be here. So let me just kind of graph that point for you guys. 0 and -2. And if you look at the graph on page 98, you see there are some arrows. And one of the arrows is indicating that I am moving 3 spaces up. So, 1, 2, 3, or whatever. So you'll have a 3. And then, so that would be -1, 0, and 1. So that's actually about here. Let me write that about here. So that would be 3, right about here. Let me erase this. So that'd be 3. And then the graph also indicates that after that, I move 4 spaces to the right. So 1, 2, 3, 4. So I move 4 spaces to the right. And I have my order, and I just connect the dots. And we saw this in our previous video, and you guys were recently quizzed on this. So anyway, you have that. And based on this equation, I want you to write a line. So what do I have? Well, I am given a slope, and my slope is, since I went 3 spaces up and 4 spaces to the right, the slope is actually 3/4. And the y-intercept is actually -2. So based on this, all I had to do is just write an equation. So y equals my slope, which is 3/4 x, minus 2, or because b is -2. And you're probably asking yourself, but if the formula is y equals mx plus b, if the formula is y equals mx plus b, why did you write a -2? Because technically, Subtracting is adding the opposite. So I could say y equals mx plus b. I can also say y equals mx plus negative 2 or plus negative b, which is the same thing as saying y equals mx minus b. So basically, if you have y equals mx minus 2 or minus b, it's pretty much the same thing as saying y equals mx plus negative b, or y equals mx minus b. So that makes no difference. So basically, just to kind of so you guys have an idea, my slope is 3/4. My y-intercept is -2. So all I did is I just wrote my answer as y equals 3/4 x minus 2. Now, you could also have the opposite. And this one, you had a graph. And it's very, let's say I gave you, and I say, well, m is 2/3. And b is 1/4. And I want you to write an equation. Well, we know that if I'm given a slope and a y-intercept, the equation is just y equals mx plus b. So I just have to plug in the numbers into the slope-intercept form. So this is pretty easy. It's very basic, and there really is not much we can do with this. So basically, I just plug in the numbers. So m would be 2/3. So you have 2/3 x. So my slope is actually 2/3 x, and my y-intercept is 1/4. So b has to be 1/4, right? And that's it. And that's how I would do it. And of course, the y, I just write y equals mx plus b. And that's pretty easy. It's pretty simple. It's nothing out of the ordinary. It's nothing too complicated. So that's pretty much example number 1. Let's move on to example number 2. Example number 2 is on page 99. In example number 2, the problem says, and I'm going to type it, it says, write an equation of a line that passes through that passes through 5 and 4. So that passes through 5 and 4 and has a slope of -3. Has a slope of -3. So here, you're being given an ordered pair. So basically, you're being given an x sub 1, y sub 1. So x sub 1, y sub 1. And which is 5 and 4. And your slope, which is -3. So what you're going to do in this case is pretty much just work with what you got. So I have an ordered pair, I have a slope, and I said that whenever you have an ordered pair and a slope, the formula that you use is what we call the slope-intercept form, which is y minus y sub 1 equals m, which is the slope, times x minus x sub 1. So x minus x sub 1. And basically, guys, all we do is plug it in and solve for y. So we're just going to plug in our numbers. Y stays the same. y sub 1 is going to be 4. The slope is being given to us, which is negative 3. And you have x, which stays expressed, times x sub 1 or minus x sub 1, which is actually 5. So all we're going to do now is, like I mentioned, solve for y. Now to solve for y, it's very easy. You're just going to use your basic algebra. So y minus 4 is pretty much, it stays the same because there's nothing I can do with this left side for now because they're not like terms. And you're going to multiply negative 3 times x, which is negative 3x, and negative 3 times negative 5, which is 15, positive 15. So now all I have to do in order to solve this is just get rid of this 4. Now I use my basic algebra. So if this is minus 4, I add 4. And this side is going to cancel out. And plus 4 on this side. So basically your answer is going to equal, I'm going to write it here. Y is going to equal to negative 3x, because there's nothing I can do with that, and 15 plus 14 plus 4, excuse me, is 19. So plus 19. And that's pretty much how I would do example number 2, which is on page 99 of your textbooks. And we're still missing one more, but I just wanted you guys to take a look at the final answer. So y equals negative 3x plus 19. And that would be that answer, okay? Now let's look at example number 3. So example number 3 on page 99 as well is basically telling us how to work with parallel and perpendicular lines. So let me actually write that here. And example number 3 says, write an equation of the line that passes through negative 2 and 3, negative 2 and 3, and is A parallel and B perpendicular to the line y equals negative 4x plus 1. I'm sorry, plus 1. So in this exercise, it's actually divided into 2 because you're working with parallel and perpendicular lines. So remember that parallel lines are lines that never intersect. So this is an example of a parallel line. And a perpendicular line are two lines that do intersect to form a 90-degree angle. So this is a parallel line, and a perpendicular line, excuse me, is basically a line that forms a 90-degree angle. So if you have two lines that intersect and form a 90-degree angle, those lines are perpendicular. Now in the last sections, two sections ago, we said that basically parallel lines have the same slope and perpendicular lines have negative reciprocals. So what does that mean? Well, very simple. Let's first start off with A, okay? And let's identify what we've got and then we'll work with what we're missing. Okay, so A, we have an ordered pair, so we're given an x sub 1 and y sub 1, so it would be negative 2 and 3. And we're not necessarily given a slope, but we are given an equation. So the equation is y equals negative 4x plus 1. Now, what does this mean? We're not given a slope, but we're given an equation. Well, the problem says this is the equation of a line. And at one point it's perpendicular and at one point it's parallel. So if A is dealing with parallel and the slope of this equation is 4, that means that the slope here is also negative 4. Okay, so we're only working with our parallel lines right now. We're saying that the other equation is parallel to this. So if it's parallel, that means that the slope is the same. So if the slope here is negative 4, so is the slope here. And what we're going to do is just use our point slope form. And you guys seen it enough already. Y minus y sub 1. But instead of writing y sub 1, I'm going to say 3 times x, or excuse me, equals the slope, which is negative 4, times, instead of saying x minus x sub 1, I'm going to say x minus negative 2 minus negative 2. And basically, y minus 3 is not going to change. So we're going to leave it as y minus 3. And we're going to multiply. Negative 4 times x is negative 4x. Well, actually, before I do that, let me look at my parentheses. So negative 4 times. Now, x minus negative 2 turns into x plus 2, because remember, whenever we're subtracting integers, we're adding the opposite. So the opposite of negative 2 is positive 2, and that would be x plus 2. And now we can distribute. Now we can use the distributive property. So negative 4 times x is negative 4x. And negative 4 times 2 is negative 8. So that'd be negative 4x minus 8. And you have y minus 3. So what's going to happen now, guys, is you're simply going to solve for y. So you're going to add 3 here. And you're going to add 3 on this side. And this is going to cancel out on this side. So this side is going to cancel out. And that's going to be y equals negative 4x. And negative 8 plus 3 is actually negative 5. So negative 4x minus 5. And that would be part A of this exercise, okay? Again, all I did was I found out, since the equation is y equals negative 4x plus 1 and it's parallel, that means that the slope is negative 4. So then I just plugged it into the slope point slope form. So instead of saying y minus 3 equals, or sorry, excuse me, instead of saying y minus y sub 1, I simply changed that to y minus 3 equals, and instead of saying negative m, I plugged in the negative 4. And instead of saying x minus x sub 1, I said x minus negative 2. So basically, x minus negative 2 turns into x plus 2. And I bring down the negative 4. And I also bring down the y minus 3. And then I just use my distributive property. So basically, I'm going to multiply negative 4 times x, which is negative 4x, negative 4 times 2, which is negative 8, and that leaves me with y minus 3 equals negative 4x minus 8. After that, all I do is add 3. Negative 8 plus 3 is negative 5, and I bring down the 4x, and y equals negative 4x minus 5. So that's the first part of my problem, which is the parallel line. Now let's do B real quick, okay? So I'm actually going to go ahead and erase this. So we can start working on the second part of example number 3, which is on page 99. And this would be the last example of this lesson, right? So after this, hopefully your doubts are clarified and you guys can work on the practice problems without any having too much trouble. So let me actually erase this and let me erase this. So we did part A, now we're doing part B. And part B, basically you have the same equation. You have the same ordered pair, but B is perpendicular. So that means that this slope is going to change. Now, when two lines are perpendicular, they are the negative reciprocal of each other. Remember that even though this says -4, technically this is the same thing as saying -4/1. So the reciprocal is to basically take this -4/1 and write it as 1/4. So just to literally turn it upside down or reciprocate it. Now, it's the negative reciprocal, which means that the signs are going to change. So that means that the if this is -4x, when I rotate it or when I reciprocate it, it's now going to be positive for 1/4. Okay, so I have my slope. All I need to do now is just plug it into my formula. So again, instead of writing y minus y sub 1, I'm going to say y minus 3 equals m. Now, instead of writing m, I'm going to change the value of m to 1/4. So I'm going to say 1/4. Okay. Now, instead of writing times x minus x sub 1, I change the value of x sub 1 to -2. So minus -2 minus -2. And basically, what you're gonna say, you have the y minus 3, and you're gonna leave it expressed as y minus 3, and you're gonna multiply 1/4 times x, which is 1/4 x. Oh, actually, first, excuse me, you're gonna I apologize for that. You're gonna bring down the 1/4, and then the x minus -2, just like in the other problem, is gonna turn into x plus 2, and now I can distribute the 1/4. So y minus 3 is pretty much going to stay the same. Equals 1/4 x, because 1/4 times x is 1/4 x. And then you have 2 times 1/4, which is 2/4. So plus 2/4. 2/4. So I'm almost done with my problem. I just need to solve for y. So again, all I did real quick was I turned the x minus -2 here into x plus 2, and then you multiply 1/4 times x, which is 1/4, 1/4 times 2, which is 2/4. Now, I can reduce this fraction and actually turn it into 1/2. So, and I'm going to see if I can do it on this side, and hopefully I have enough space. So if I can reduce that fraction, this fraction right here, I'm going to turn that into y minus 3. Again, I'm just doing this extra step so you guys know what's happening. You don't have to, you can skip it just as long as you know that 2/4 can actually be reduced into 1/2. 1/2. Now, I need to solve for y, so I have to get rid of that -3, so that means I have to add 3 on both sides. So I'm going to go ahead and add 3 here, and this would be plus 3. And 1/2 plus 3. So basically, this side is going to cancel out, leaving my y isolated. So I have y equals 1/4 x. Now I'm going to explain something to you guys. I mentioned it in class, but I'm going to explain something to you guys. Because this is something that can only be done when the fraction that you're adding is 1/2. So basically you have 1/2 plus 3. Now you could do the part where you look for the least common denominator, and then just kind of equal everything to that and solve it. But there is something that can only be done when I'm either subtracting or adding 1/2. Now, 1/2, if I would have turned it into a decimal, would be 0.5, right? And 3 plus 0.5. So let me do it on this side. So I can turn 1/2. I can turn 1/2 into 0.5, right? And then I can just add 0.5 to 3, and I can just say 0.5 plus 3 is 3.5, right? And that's 3.5. So that's one thing I can do. And that would be 3.5. So yes, I can just say, well, 1.5 plus 3 is 3.5. And I could just say, well, y equals 3.5. Or another thing that I can do is, because I have 1/2, I know that 3.5 is the same thing as saying 3.5. So basically, what I can do is just say, well, 1/2 times 3 is actually 3.5, and it's a mixed number. And I can turn that mixed number into an improper fraction. And 2 times 3 is 6, plus 1 is 7. And my final answer would be y equals 1/4 x plus 7/2, or 7/2. And that would be your equation if the lines, or when the lines are actually perpendicular. So ladies and gentlemen, this is first 3 examples of section 2.4, equations of graphs. They're found on page 98 and 99. I have already uploaded to College One the exercises that you guys need to do for practice. So hopefully this video will help you guys out, and have an awesome day, and we will see each other in our next class. So bye.